Today we're going to discuss continuity. Suppose you have a function, let f of x be a function with domain D. Function f of x is said to be continuous at x equals to a if the following conditions are met. So you need to check three conditions. The very first condition is, first of all, f of a is defined. What's the meaning of that? It means that a belongs to the domain of the function. The second condition, the limit exists. The limit of f of x as x approaches a exists. What's the meaning of that? It means that limit from left is the same as limit from right. Well, and finally, the limit of the function as x approaches a is equal to the output value of the function. If these three conditions are met, then we say that, hey, we have a continuous function at x equals to a. Let us discuss continuity of some functions. Example. Suppose we have the following graph of the function f. You have your function with given graph. You have just a piece of a function. The function has a whole. And suppose this is 1. Is function continuous at 1? Let's call it f of x. Well, let's check the definition of continuity. We know that f of a must be defined. What's the meaning of that? It means that a must belong to the domain of the function. So you can say that since 1 is not in the domain of the function, so the function is not continuous at 1. What about function g? Suppose we define function g to behave like this. And we want to analyze the continuity of the function at 2. Is function g of x, let's call it function g, continuous at x equals to 2? Well, you might say that, hey, 2 belongs to the domain of the function, but since the output value of the function is different from the limit, so the function is not continuous. X equals to is in the domain. There is no doubt there, but the limit of the function of function g of x as x approaches 2 is different from g of 2. G of 2 is going to be a number here, but the limit is going to be a number around here. So again, the function is not continuous. Is not continuous at x equals to 2.